neutrinos here, protons, neutrons and electrons. These are very tiny particles usually to make up atoms. Here neutrino is also very tiny particle. It is otherwise called as a tiny elementary particle, but it is not a part of an atom like this. It is not a part of an atom. But neutrino has a very tiny small mass but no charge, and it spins half. It spins very half, and it interacts very weakly with other matters, other matter particles here. So it is unlike a proton, neutron and electron. It is not a part of atom also, but it has a mass and can react very weakly or interact very weakly with other matter or particles. So how these neutrons are formed? First, neutrons comes from a sun called as a solar neutrons, and other stars also, other stars, cosmic rays, and that come beyond from the solar system. If this is solar system, beyond the solar system, that comes from here, the origin of neutrons. That means from Big Bang, from which universe was originated, and they can also be produced from laboratory. That means from Big Bang they are naturally formed and can also be prepared in the laboratory. And how many types are there neutrinos? Neutrinos are mainly of 3 types here, or otherwise they are called as flavors, 3 flavors. So first one, what is that here? Electron neutrino, tau neutrino, and muon neutrino. So how many types are there here? Electron neutrino, tau neutrino, muon neutrino, and they can change from one flavor to another flavor in the travel, as they travel anywhere. And this process of neutron oscillation is an unusual quantum phenomenon. It is called as unusual quantum phenomenon. Unusual quantum phenomenon. So are these atmospheric neutrinos produced in nature? Yes. How they are produced here? Atmospheric neutrinos are produced from a cosmic rays which consists of protons plus heavy nuclei, and these collide with the atmospheric molecules such as nitrogen to give off pions and muons, which further produce neutrinos. So you need to remember that these are produced from the cosmic rays that consists of heavy nucleus, and then it also collides with nitrogen, and then it gives off pions and muons, and further they give it as neons. So these are very important in the field of science and technology and in the field of science. How it is helpful? It helps in the properties of sun to find, and the visible light, that means the visible light spectrum will be there. So from the sun, whatever it is emitting, we can read that, and also neutrinos may also make the very close to this time to reach the sun, known as solar neutrinos, were produced in the core of the sun. So in the core of the sun it is produced, and therefore they give us information about the interior of the sun. So these neutrons will help us to find out the sun. So what makes them? Universe is made up of the properties of neutrinos. Understood better, they can be used in the astronomy to discover the universe, how it is made up of. If we find neutrinos, then we can know how universe is made up of, and then very larger galaxies coming out from the distance past can also be known, and these can also be a clue about the origin of universe and early stages of infant universe. That means the smaller universe, how they are forming, will be known. And also in the field of science, how they are helpful means X-ray machines are there, and PT scans, MRI scans, all come out of research into particle detectors. The Indian National Observatory, Neutrino Observatory detectors may have applications in the medical imaging, and then we just find out what are the important elements are there. So what happens in Indian Neutrino Observatory? So in India, Neutrino Observatory is going to be established here, and it is an effort aimed to of a world-class building underground laboratory. So it is located underground. Understood. So about Neutrino Observatory here, if we say where it is going to be located means here Pottipuram village in Theni district in Tamil Nadu Kerala border. And why it is going to make means the initial goal of the Indian based Neutrino Observatory is to study neutrinos. Neutrons are small particles that form the universe. Highlights: two underground laboratory caverns with a rock cover of 1000 meters, that means 1 kilometer, tunnel of 2 kilometer length is going to be made, and where in Canada, Kamioka, Japan, SNO, Gran Sasso, Italy, and underwater in Amundsen, Scott, the South Pole Station, Antarctica, and Antheris under Mediterranean Sea off the coast of Toulon, France. And INO, to discuss very neatly, it is located underground. Why it is located underground means here for the purpose of making neutrinos, as mentioned before, they are notoriously difficult to detect in laboratory. So because of their extremely weak interaction in the matter, the background from cosmic rays which interact much more readily than neutrinos, and the radioactivity will make it utmost, and it is impossible to detect them on the surface of the earth. So what will happen here? This is the reason most of the Neutrino observatories are located deep inside the earth's surface, and the overburden provided by the earth matter is very transparent to the neutrinos. And whereas most underground or the background from cosmic rays is substantially reduced depending upon the depth of the detector where it is located. And one of the earliest laboratories which is located or created to detect neutrinos underground only, and in the world was located nearly 2 kilometer depth at a Kolar gold field mines in India usually. And the first atmosphere neutrinos was detected in 1965. It was later that the laboratory has been closed due to closure of the coal mines, and after that observatory is of no use. And then most underground laboratories around the world are located at the depth of 1 kilometer or larger than 1 kilometer, and most of them are of two types. Underground laboratories either located on the mine or road tunnel. So these are two types, and there are four major laboratories around the world. First one is Sudbury in Canada, and Cameo, that means here I am rubbing. Nearly four are located to remember: Sudbury in Canada, Kamioki or Kamioka in Japan, and Gran Sasso Mountains in Italy, and Soudan Mines in USA. These are the four, and several others are also planned, including INO in India, which is an attempt to recapture the pioneering studies of the neutrinos at KGF. So then what is the based neutrino Indian based Neutrino Observatory? It is a proposed pure science underground laboratory, and primary goal is to study the interactions between the natural occurring particles called as neutrinos. And there is a worldwide interest in the field due to implications of several diverse allied fields such as physics, cosmology, and the origin of universe, and energy production, mechanisms of sun and stars, etc. How universe is formed, this all are there. In fact, neutron labs also underground have been running for several years in places such as Japan and Italy, Canada. These experiments are proposed by INO and will be a complementary in nature with existing ones. That means INO also will be collaborating with all the other world-class Neutrino Observatory centers, and they conduct the experiments depending upon suns, stars, and everything. And this is a picture you are seeing in Tamil Nadu and Kerala border, where they are able to start the Indian-based Neutrino Observatory, INO. And this will study the naturally produced interactions of cosmic rays on the sun's Earth's own atmosphere. And several groups belonging to different universities, IITs, and research institutes in India are taking part of this work also. And research development of INO components are also going on. And it is a collaboration to join with another scientific institutes overall India. And the current proposal focuses on neutrino detection. Where the neutron particles are there, it will detect, and it will detect the static detectors, that it will place the static detectors to the very deep of the earth. Understood. So this is about the Indian based Neutrino Observatory Center. At present, nearly 26 institutions and 100 scientists are involved in this collaboration. And very famously, to know that Tata Institute of Fundamental Research in Mumbai is also going to collaborate with this, and it is expected to grow further. And the laboratory is located, which is in Tamil Nadu. It finds the iron calorimeter, CAL, iron calorimeter detector is going to be placed to detect the study of neutrinos, and it also helps in physics, biology, geology, and everything. And this ICAL, what we are making in India at Tamil Nadu, will be installed in INO laboratory, and after that this will become a world's most massive detector. Such an effort will involve INO observatory or industry in a big way. No issues related to the mechanical structure, electronics and base detector related technology. It is being developed completely indigenously, that means made in India itself.